tomorrow. That's not on that little chart. So you're going to find your reject region. If your p-val, if I give you your p-val as 0.0089, inverse norm, find me where it's cut off. P-val, your area under your curve, find me where it's cut off. This applies to when you're looking for your level of significance as well. If you're looking for 0.01, inverse norm, 0.01. If you're looking for 0.10, inverse norm, 0.10. A two-tail test is different. We have to share it. But a right-tail test, if you do a right-tail test, you can look up that area and use the positive of it, or you can do 1 minus that area. That's up to you. But when you do your cutoffs, you're going to need to know these. The ones with the 2, and the big difference is when we did your level of confidence, we did the 1 minus because it's like 95%. We're on the flip side of that. There's no 1 minus anymore. It's just take this and divide it in 2. Okay, share your tails, and they both have to be the same number, 1 a negative, 1 a positive. Okay, 17 and 18. This was nice. You're going to use your calculator. They used their calculator. They gave you the steps. Even if it doesn't matter what your claim is, all you're interested in is your p-val. And you're testing against their level of significance. So this is strictly a p-val test. Your calculator returns your probability curve. You test against your level of significance. Make sure you line it up in that order, because if you don't, you're going to have to flip your signs around. So keep it lined up in that order. You have to test with p-vals. You don't have to use your calculator. No, you don't have to use your calculator. Yes. 17 and 18. Guys, 17 and 18, it's giving you the level of significance. This is your level of significance. This is your p-val. It's asking you to test your p-val against your level of significance. All this is asking you to do is a test.
Alright.
So set up your p-val to your level of significance. Fill it with zeros. Who's bigger? 630 is bigger than 500.
Yeah.
You're greater than, you're failed to reject H0. That's all at once. Here your level of significance is 0.01. Fill it with 0. 6 is less than 10. You reject H0.
Do we have to put the bigger number first?
You have to put the p-val first.
Alright.
The bigger number is whatever you determine to be the larger number. But the p-val, here's the problem. If you don't, and you put your level of significance first, and then you test your p-val, you can't go by this chart. You got to flip the signs because you interchange these. So don't do it that way. Make sure p-val comes first. I'm going to give you this chart, and I'm going to leave it up here as well. So all you have to do is line up your p to your level of significance. Fill it with zeros and make a decision. Good? P-val is probably the easier, especially if you use your calculator. And 21. My 20 and 21 are reversed. So this is 20. And 21 is above it. So this is what you need to remember how to do. Find your critical value. This is your cutoff point. This determines where it's going to be in the reject region and where it's going to be in the failed to reject H0. If it's a left tail test, you're great on the inverse norm. It's always area to the left. Inverse norm, no 1 minus. Area to the left, find your cutoff point. You call it a Z sub 0 or a Z sub C. Doesn't matter. Your right tail test, 2 ways. Put it in and realize it's going to say negative 1.645, but since you're on the symmetric right side, it's positive 1.645. Or you could do 1 minus this. and then it will give you the positive. I like to not use the 1 minus because then you get confused on where to put the 1 minus. Right, so you're going to label, when I ask you to do that, you're going to label this reject H0, and you're going to label this fail to reject H0. I do like this way. The only extra thing is finding your critical value. But once you find your z-score, it's a visual. It's right there. It's in the reject zone or it's not. Everybody can do this? Okay, because you're going to have to do this on the test as well. A two-tail test, you're sharing, that's 0.02. God bless you. So inverse norm,
Thank you.
either 0.02 divided by 2 or just 0.01. You can put the 0.02 divided by 2 right in your inverse norm. That's what's nice about the inverse norm. You can put it right in there. Because it's two-tailed, you have to share it. Right. Now both of these are reject H0. This is fail to reject H0.
When do we apply it by to?
When you get your answer for your z-score, your test statistic, you do your z formula, and then you find your area, that's when you multiply it by 2.
Okay.
Questions?
Could you scroll back up, please, for the other one?
Yeah. 20 and 21 are swapped around. Okay? All this one did was help you identify what zone it's in. I like, this is where I like the reject. Because here's your cutoff point. 1.98 clearly falls to the right. This is a number line. To the right of 1.96. Think of money. $1.98 is more than $1.96. Think of money. So I'm in the reject H0 zone. That's my decision. Negative 189 is falling right in here. It's not as much as owing negative 1.96. It's falling right in here, right before it. You're in the fail to reject. 1.65, you're in the fail to reject. And negative 1.99, you're in the reject H0. Close, but you're still in the reject H0. And just a heads up, make sure you say reject H0. If you just use the word reject, it's wrong. Because we don't know what you're rejecting. So you have to use the words, you have to use the right words on these guys. And I am going to be real strict about it. Very. Okay. Now, you'll get one that walks you all the way through. So here's a company that makes cola drinks. States that the mean caffeine content per 12-ounce bottle is equal to 40 milligrams. Your mean is equal to 40. There's your claim. Okay, states, claims means the same thing. You work as a quality control manager and you're asked to test this. During your test, you find that a random sample of 20 bottles, 12 ounce has nothing to do with this. Has a mean caffeine content of 39.2. There's your sample with a population standard deviation of 7.5. And your level of significance is 0.01. Can you reject the company's claim? Remember, we see the word reject. We know the claim has to be the HO. If you see the word support, the claim has to be the HA. So that kind of helps you right there. Did you start it off the right way?
There was a right tail test. Would you just do 1 minus that and then inverse norm?
I wouldn't, yeah, you can.
That's right.
Yeah, you
And
can.
if it's 2 tail, you just divide by 2.
Divide by 2.
And then inverse norm?
This is a divide by 2. 2 tail. Yeah. Okay. Sketch. I'm going to need a sketch. So you sketch. You have a 2-tail test. This one, we did your reject region. The direction 6 part said reject region. You had to find your critical value. So since you have 2 tails, you have to share 0.01. You divide it by 2. Look up in your inverse norm. Okay. This is your test statistic. This is your critical value. This is your test statistic. This is from your test information, your sample of 20. Don't forget to use this forever to bend on the bottom. After you find your z-score, just look to see where does it fall in your sketch. So negative 0.48 falls right here, pretty close to the 0, doesn't it? So you're going to fail to reject H0. Then you're going to follow your chart. You're going to say your claim is HO. If you fail to reject HO, there's not enough evidence to reject the company's claim that the mean caffeine content is 40 milligrams at a level of significance of 0.01. That means he made a good statement. He did his research, he made a good statement, according to your sample that you tested. I might even want to test again. That's kind of way in the middle. Either that or he's got a really good claim. So, falling in the middle there somewhere. Questions? Can everybody do this?
Yes.
Okay.
Everyone.
Everybody but Oliver. Okay. A light bulb manufacturer guarantees that the mean life is at least is greater than or equal to. That's the HO. Good. A random sample. Here's your information from your sample. A sample mean of 745 hours. Your population is normally distributed. Because you only sampled 25, they had to tell you that. And your population standard deviation is 60 hours. At a level of significance of 0.02, do you have enough evidence to reject the manufacturer's claim? Again, find your critical value. This is your inverse norm, 0.02. This is your critical value. This is your cutoff. This is your test statistic. I want you asking me tomorrow, what's my test statistic mean? This is what you tested. This is your sample that you're testing your claim with.
Wait, so test
It says statistic
Z-score. That's your test statistic. That's what you're testing against this claim. Somebody makes a claim about the population. You pull out your sample and you test it through your Z-score. Your critical value is your cutoff point. So your z-score falls at negative 0.42. So you fail to reject. You're in your fail to reject H0. There's not enough evidence, the same as the last one, to reject the claim that the mean life bulb is at least, the mean life of a certain light bulb is at least 750 hours. Now, if you're testing p-val on this, if this is a p-val test, what do I have to do?
Write down your p-value first, but you have to take a z-score and look up the area under the curve.
Good. Now, it depends what tail I'm in, right?
Yeah, it does.
My tail is my left tail.
You don't have to just look it up.
You just look it up in your table. Look up negative 0.42. Find me the area under the curve. So let's find that area and test with the p-val while we're here. If this is a p-val, you do not have to find your reject region. But you do have to find me this.
0.3372.
0.3372. Okay, now I'm kind of eyeballing this. It has to be less than 50%. It's a pretty good chunk there. So we test this. This would be my p-val, my area under the curve. So we test this against your level of significance. My level of significance was 0.02. Fill it with zeros. You are greater than. Your
Fail to
decision,
reject.
fail to reject, H0. No. Now, in your calculator, when you do this in your calculator, well, yeah, but it's not as visual as this. Like when you say greater than, you're really just putting it in those words and say greater than, fail to reject. I like the visualness of looking at the sketch.
So you like
That's what I like. So when you do your calculator test, your calculator gives you p-val as well as z. Let's put this in your calc for all of you guys that are still a little bit leery of this. You're going to go to stat, you're going to go to test. You're at the very first one, z-test. You're going to put in your own statistics. Your population mean, that's your U, that's your 750. Your standard deviation for your population, 60. Your X bar, that's from your sample. Your N, how many did you sample? 25. Now, this tail follows the tail of your HA. You are less than. However your tail points for your HA, follow the point. Calculate. There's your test statistic. There's your z-score. There's your p-val. Okay, so 0.42, negative 0.42, and 0.3385. It's a little slightly off from ours because of the rounding. Your calculator has a better access to the full table. We're rounded our z-score, and we had to look up a rounded z-score. They don't. So calculator step is very nice. It'll allow you to bypass this part. You still have to set the claim up, you still have to set the sketch up, and you still have to make your decision.
Any other kind of problems that just asking them some other stuff?
That's it. That's it.
These?
That's it.
It's all word problems?
Well, no, they're not all word problems. I kind of made it